Today we will talk about what normals are, normal maps, and how to create them. Normals are needed for the program to understand how properly eliminate your model. They exist for polygons, allowing to show which way they face and where the outer and inner parts of a model are, as well as for vertices, allowing you to set the hard edges or soft edges. Normals are used in various functions that you apply to models. For example, extrusion occurs in the direction of the normal. But you don't have much control over the normals themselves. You can only flip normals of polygons and specify how hard the normals of vertices are, and that's about it. But things get more interesting when we apply a normal map. It's a texture map that tells you how light should interact with your model. It's applied to the normals of polygons to create the illusion of additional details on the geometry. What happens is that we add elements to the normal map, and they appear embossed on the model, due to the way light begins to interact with the surface. But no additional geometry is added, and if you look at the model from a low angle, it will be flat. Normal maps are often used for optimization, as that method allows you to not add new geometry or apply displacement map, which can be more time or resource intensive. Normal maps look like this. They are colorful because each of 3 color channels contains information. Basically, it's 3 texture maps in one, each of which contains information about how light should interact with your model. There are 2 methods for creating a normal map. You can manually add the necessary details to the map, for example using a substance painter, or you can use baking. This method is used to preserve details when simplifying a model's mesh. For example, if you created a highly detailed model with several million polygons in ZBrush, but need to reduce it to 50k polygons, you can use baking to preserve the details. To do this, you create a model with the desired topology and then overlay the original high poly model onto it. The software then projects the high poly model onto the low poly model and identifies the difference in details between them, which are baked into a normal map. This process is commonly done by using software such as Marmoset, Substance, or XNormal. All normal maps are divided into types, OpenGL and DirectX. The only difference between them is that the green channel is inverted in the one compared to the other. But this is no problem, and you can easily convert one type to another just by inverting the green channel. And on the screen you can see a list of which programs need which normal maps. Also, normal maps have so-called spaces. These are the coordinate systems in which normal maps are defined. The 3 main spaces are tangent space, object space, and world space. In 99% of cases, you will use tangent space, as the other options are not better, but they don't allow you to deform or animate the model. Let's summarize. Normals specify how light interacts with the model. Vertices and polygons have them. With vertices they allow you to make a smooth or hard edge, and with polygons they represent where the outer and inner parts of a model. In addition, there are normal maps that allows you to add detail to your model without needing a lot of resources. And you can create them either by manually adding details to the map or by using baking to save details on an optimized topology. That's it, thank you for watching, hit like and subscribe, and I wish you sharp details.